Indium, with its atomic number of 49, boasts a relatively low melting point of 156.6 degrees Celsius. Its excellent thermal and electrical conductivity further enhance its suitability for a range of applications. Indium is also highly ductile, meaning it can undergo significant deformation without breaking. Indium is typically extracted as a byproduct of zinc and tin mining. The refining process involves various techniques to produce high-purity indium ingots. Indium's versatility shines through in its applications. In the world of electronics, indium is crucial for manufacturing touchscreens, liquid crystal displays (LCDs), and semiconductors. Its unique properties also make it an essential component in solar panels, ensuring optimal energy conversion efficiency. Additionally, indium's malleability and low melting point contribute to its use in various soldering applications. When it comes to indium, Stanford Advanced Materials stands out as a reliable source. With a commitment to excellence, SAM provides a comprehensive range of indium-based products, meeting the stringent demands of industries worldwide. Explore their offerings and learn more about their commitment to quality at www.samaterials.com.